As mentioned earlier, the game is fully autonomous, which means you're going to have to trust in your robot. Any manipulation of the robot, such as driver control of any kind, touching the robot, or manipulating the sensors from outside of the field, is considered illegal and could result in disqualification. Now that that's out of the way, there are some considerations when you are building your robot. The structure has many ramps, so within the drive base, there are two main things you need to consider. First is the choice of wheels. Here on the starter bot, we're using traction wheels. These provide a little bit more grip than Omni wheels and prevent the robot from sliding sideways, which is important when considering an autonomous game, as sliding would cause some uncertainty with your code, and of course you cannot manipulate the robot during the game. Secondly is a high torque configuration is what we're using on this starter bot here. High torque will allow the bot to more easily travel up the ramps and hopefully cause it to not slip or slide when it's traversing the field. Secondly, clearance. When going up ramps, clearance is a very important factor, as if you do not have enough clearance, the robot could get stuck on the ramps, especially here in the front of the drive base. So on this starter bot, we've got quite a high clearance here, as the drive base is quite short. This will allow it to go up the ramps without getting stuck. And secondly, we've used pneumatics here on the intake to prevent the intake from dragging on the ramps or on the floor. And thirdly, the structure is quite small, so the robot size is very important. We've got quite a thin drive base here, about 24 centimeters wide, and also quite a short drive base, about 30 centimeters long, to make sure that the robot is able to drive in the passageways and make turns within the structure without getting stuck. So there are two main portions of the example code that we have put up for everyone to use. First is initialization. Before the robot starts operating, we need to make sure that it always begins in the same state. So the first thing we do is we tell the robot to retract its pneumatic pistons. Next, we set the drivetrain's velocity and torque to the right levels. Then we turn on the lights for the optical sensors to detect colors. And finally, we reset any variables that our algorithm needs. By doing all of this, the robot always starts in a clean and predictable state every time we run the code. Next, we get onto the main code. So we start this by running a continuous loop. The robot will keep moving forward until it detects a red acrylic sheet. It does this using data from the optical sensor, which allows it to recognize the color red. Once the robot sees the red acrylic, it keeps moving forward until the distance sensor measures 1.3 inches or less. At that point, the robot will turn left by 89 degrees. Through testing, we found that 89 degrees works best, because when we set it to exactly 90, the robot wouldn't be able to correct itself exactly to the position we wanted and would end up driving off the track. This is where we apply a proportional controller. Here's how it works. When the robot is told to turn 89 degrees, it might actually stop at 85 degrees, as an example. That gives us an error of 6 degrees, since 95 minus 89 equals 6. To correct this, we multiply the error by our proportional gain, or KP, which will tell the robot how much more to turn. We do this because if the error is too small, the robot won't be able to move at all due to the friction between the wheels and the floor. We also set a tolerance in this step. That means that the robot will keep correcting itself until the error is smaller than the tolerance. For example, if the tolerance is 3, the robot will stop correcting once the difference between its current orientation and the target orientation is less than 3 degrees. Finally, the direction of correction depends on the robot's orientation. If the heading is less than the target, it turns right. Otherwise, it turns left.